Good morning, everyone. I will give a quick introduction about my company and the material we're introduced to the market. Arkema, it's a large chemical company. So by 2024, our revenue is about $10 billion. We have like 21,000 employees worldwide, and we operate worldwide, and we have around like 20 R&D center. I has been located from China to US since the beginning of 2022, and my colleague Mikhail and I come for this trade show to introduce Piezo material. He's from France. I'm original from China. Who needs the opportunity to practice English is giving the presentation today. And so I apologize for my strong accent. Okay, and so for Piezo, which is a small business unit under Arkema, we make a Piezo material. It's a polymer base, and it's basically convert the mechanical movement to electricity. It works in another way, which means when you apply electricity, the material will deform it. And so when we talk about the Piezo, people always think about, okay, ceramic. It's not the ceramic based. We do a polymer based. The advantage of a polymer versus traditional ceramic Piezo material, it's printable, it's flexible, and its cost is more effective, and it's recyclable. We're not recycle it today, just recyclable. Yeah. I don't want to like a greenwash for that. Okay, so for application for our material, mainly it's for two main application: sensor and actuator. For sensor, because as here you can see, it's Piezo. So when you apply electricity, when you bend the material, when you have any kind of mechanical movement, this material will generate voltage. So the application for the material is always like sandwich. You have a top electrode, bottom electrode. Our active material is in the middle. So when we bend the material, you scratch the material, you put pressure on the material, the voltage will be generated. So that is the output. And in terms of the mechanical movement, where we can capture from pressure, deformation, bending, they can capture sound and impact shock and ultrasound. So as I mentioned, it can work in another way around. So when we apply voltage, and then the material will deformate. So we use it as an actuator. Just give some comparison or idea about how to use our material. So in terms of use our material, we can place standalone, or we can combine with some other sensors. For example, for a standalone, we use it as a force sensor to capture all kinds of dynamic movement. But it's not only can stand alone. We can combine to use this material with capacitive sensor or resistive sensor. For example, for capacitive sensor, where it's when you activate, it's very sensitive. So you may touch it, active some function you don't want active. It's maybe an accent, you touch it, you active. So in order to add one more, like say a security layer on that, we call it a force security capacitive sensor. So we combine the capacitive sensor with our force sensor. So when we want to active something, we need to put the pressure on it. So make sure that is a function we want active. Another example is we combine to use with the resistive sensor with our piezo sensor. Resistive sensor is well known to capture to get the static pressure. So you stab on it, you capture that, but they don't grab the dynamic information. So combined with this, you get the dynamic information as well. A typical application could be a smart sleeping mattress where you have the resistive sensor in the large surface. You know, people is lying